Okay, so here's our Zome version of it. So tell me what you think about this, and we'll try to manipulate it a little bit. Can you slide it just about a little bit closer to the stairs? There we go. Perfect.
Well, it was a lot harder to build than I thought. So we built the original icosahedron first. Then we added in the red struts, and then we connected up all the other vertices with blues. And it turns out the intersection points, like we noticed those a little too late, so that we just sort of have blue struts crossing each other.
Uh-huh.
And if we had probably a little bit more time, we could have manipulated it so that a zone ball could go here.
Yeah, well, maybe we'll end up trying again, figuring out how to mark off those intersection points. But for now, why don't you show we'll try to recreate some of the projections.
You can sort of line it up like this, sort of an overhead perspective.
Okay, so are you trying to have the camera look straight down?
Yeah.
From a point? Okay, that's real good right there. Okay, so what are we looking at here?
So this is just one set of 5 faces, and the camera is sort of looking at the center. And you can see sort of into the shape, and it also pretty well, it allows you to see the pattern of the star and then the pentagon in the middle.
Okay, nice. Sorry for my coughing. Do you think you can find that hexagon projection?
Yeah, I think so.
Where does the camera have to look to see that hexagon?
So I think the center would have to be around this middle belt of triangles, sort of looking down like this.
The middle belt. So
like, if you could imagine these 2 sets of 5 faces on the ends, and then there's sort of these triangles wrapping around it.
Okay. And so where are we trying to look to see the hexagon?
I think we'd have to line it up on one face.
Okay.
Like that.
Interesting. It's definitely tough to see, but maybe I'm not sure. I think that it might be easier to see the hexagon on the computer.
Yeah.
So why don't you give it to your brother now? And you can.
So I think mine was, if you look sort of straight at an edge, then this vertex should line up with the vertex behind it.
Uh-huh.
This one should line up with the vertex behind it, and then these top 2 and bottom 2 should line up.
Okay, so hold it. Actually, you moved out of. Sorry, I was looking at it. So very nice. Now tilt it back towards you just a little, and there we go.
It might not work just because our diagonals are kind of bent because we did bend them around their intersection point.
No, it looks really good actually. So put your hand on the very top one, the top zone one closest to us, the zone ball closest to the camera, right there. Yep. So looking straight down there, we actually see that diamond. Can you point out the diamond?
It's a diamond around that one.
So that's the middle of the diamond.
So like this?
Yeah, that's the diamond. And each of those are 2 vertices that are right on top of each other.
Yeah.
And then the other, so that gives us 8, and then the 4 on the outside. Yeah, nice. We found it. Okay, cool. So what do you think is easier, having now played with the Zome shape? Is it easier to see them in the Zome, or is it easier to see these projections on the screen?
I think it's easier to see them in the Zome if you know what you're looking for.
Uh-huh.
But on the screen, it's easier to find things.
Yeah.
All right, and the camera is telling me we have 1 minute left of filming time. So the last question is, do those pentagons that you saw on the screen that you thought maybe form a dodecahedron, do they?
It looks like they do.
If these were all connected, I think they would.
Okay, that is amazing, actually. So there are pentagons inside of the shape, and we get an or a dodecahedron inside.
Yeah.
All right. Well, we are out of battery time, so good project, guys.